Hello guys, today we will gonna learn about numbers. Yes, you heard it right. Today we learn about numbers. Now we have many types of numbers, right? Can you name some of the types which you learned in the previous classes? Like natural numbers, whole numbers, integers, rational numbers. So like that there are many types of numbers. All together, all these numbers we can tell it as number systems. What we can call them as? We call it as number systems there. In today's class, we will gonna learn about certain numbers. Now we have many types of numbers, right? Now we're gonna recall some of the numbers which we learned in the old classes. First is natural numbers. So what do you mean by natural numbers? Natural numbers are basically the counting numbers. Means these are the numbers which you can count, or simply in simple words, numbers starting from 1 and to the infinity, we call them as natural numbers. Natural numbers are denoted by the symbol n. So here we will draw a diagram which represents natural number. Okay, clear? Then we're gonna expand this circle with other numbers also. Next we'll go for whole numbers. Okay, so what do you mean by whole numbers? Whole numbers are basically the numbers including 0, means natural numbers. So what are natural numbers? Which starts with 1, right? From 1 to infinite, right? Along with this we'll also add 0 there. What we'll add? We'll also add 0 also. So whole numbers means what? 0 plus natural numbers are basically the whole numbers. We denote whole numbers with the symbol as W. So you can draw one more layer as whole numbers. Next, we learnt about integers. So what do you mean by integers? Integers are the numbers, you can say, whole numbers and as well as the negative numbers. So in a number line, when you see, we have 0. On the right hand side, we have the positive numbers. All from 1 to infinity. Okay, we call them as positive numbers. What we call them as? We call them as positive numbers. And below the 0, we call them as, on the left hand side of the number line, we call them as negative numbers such as -1, -2, -3, and it goes on infinitely. All these numbers we call them as integers. What we call them as? We call them as integers, and integers is represented with the symbol Z. Why? You can name in the comment box. So we can add one more layer as integers. Now there is one more question for you. Is 0 positive number or a negative number? You should answer in the comment. Next we'll go for the rational numbers. So what do you mean by rational numbers? Rational numbers are the numbers, you can say, which can be written in the form of P by Q. Means any integer, any number, let it be whole natural number or whole number or integer, you can say, we can write them in the form of P by Q or in the form of fraction. Okay, now for example, 3 you can write in the form of 3 by 1. 5 if you take, you can write in the form of 5 by 1. -25 you can write it in the form of -20 by 1. Like that only, all the numbers, you can say, integers, whole numbers and natural numbers, we can write them in the form of P by Q. Other examples such as 2 by 5, 4 by 10, all this, 1 by 2, 3 by 4, all this which can be written in the form of P by Q, we call it as rational numbers. So what are the criteria are there for rational numbers? First, it has to be written in the form of P by Q. That is the first thing. Second thing, the Q should not equal to 0. Means the denominator which you are writing, which we represent with the symbol as Q, it should not be 0. It should not be 0. Means you can't write 5 by 0 or 3 by 0, right? These are not actual numbers. Then hence these are all not rational numbers. So we can add one more layer as what? Rational numbers. And rational numbers are denoted with the symbol as Q. So you can do one more circle as rational numbers circles. Okay, understood till now? So totally we learned about natural numbers, whole numbers, integers and rational numbers. Now everything can go through an arrow mark. So you can draw like an arrow mark. Means all natural numbers can become whole numbers. All whole numbers can become integers. All integers can become rational numbers. But you can't do opposite or vice versa. So whenever in the exams they ask this question, okay, are all whole numbers integers, yes or no? They ask like this questions, right? So you get confused how to write it or not. Draw this map and you can see if the integers, okay, if it is going on the upward direction, then answer is yes. If it is coming to the downward direction, then it is wrong. So in the question they have given is, are all whole numbers are integers? So above whole numbers we get the integers, so it's an upward direction, then yes. But you can't do downward direction. You can't say that all integers are whole numbers. Understood? Yeah. So that is the thing. So all it goes on upward direction. Now we also have another set of numbers which we call them as irrational numbers. What we call them as? We call them as irrational numbers. So what do you mean by irrational numbers? What do you mean by rational number? Recall that. It can be written in the form of P by Q. So any rational number we can write in the form of P by Q, where Q is not equal to 0. That is the definition of rational numbers. So the definition of irrational numbers will be the numbers which cannot be written in the form of P by Q. Means there are certain numbers which you can't write them in the form of P by Q. Those numbers we call them as irrational numbers. Now for example, you can take root 2 pi as pi value, then root 5, root 10. All this comes under irrational numbers. Now you have a doubt. How can we say that these are all irrational numbers? That we will learn in the next session. Before proving certain number as irrational numbers, first we need to know what do you mean by decimal expansion. Now in the previous section we learned about irrational numbers such as square root 2, pi, root 5. Now these are all what? These are all irrational numbers, right? So how can you say that these are all irrational numbers, whereas 2 by 3, 5, minus 26, all these are rational numbers? How can you separate these both? To understand this, first we need to know what you mean by decimal expansion. So decimal expansion is basically whenever you divide any number. So whenever you divide any number, you can say in the remainder. In the remainder, you already know that remainder, right? So in the remainder, there could be mainly 3 types of remainders which you can get. What you can get? You can get mainly 3 types of decimal expansions. Okay. The first type of decimal expansion is terminating. Terminating decimal expansion. So what do you mean by terminating? The word itself, sir, terminate. What do you mean by terminate? Means to stop or to end. That is the meaning of terminate. Means whenever you divide any number, for example 4 by 2, okay, when you divide this number, what you get? You get the remainder as what? You get the remainder as 0. So whenever you are getting any remainder as 0, those type of decimal expansion we call it as terminating. So you can take any number. You can have 10 by 2 you can take, okay, 77 by 11 you can take. So whenever you divide this number, you get the remainder as 0. We get the remainder as 0. So these types of decimal expansion we call them as terminating decimal expansion. Next we have non-terminating decimal expansion. Non-terminating and recurring decimal expansion. So what do you mean by non-terminating? Non-terminating means what? Which doesn't stop. Means where you don't get the remainder as 0. Where you don't get the remainder as 0. And it is also recurring. Recurring in the sense means you always get the repeating number. So in non-terminating decimal expansion, what happens? If you divide that number, it goes infinitely. What it goes? It goes infinitely. It goes infinitely. Means the number will never stop. You'll get lot after decimal, after point, you get many certain numbers. Like that, it goes on forever. But as it is going forever, it is also recurring. What do you mean by it is also recurring? Recurring means what? It is repeating. Repeating means you only get certain type of pattern there. Now for example, if you take this number, okay, 0.25252525, which goes on forever, right? Now this number is non-terminating recurring. Why? First, non-terminating means what? It is going infinitely. And second thing, although it is going infinitely, it is going with a pattern. What is the pattern here? What is the pattern which you notice here? That is, it is coming like 2525. 25 is the pattern which you're getting here, right? So if any number, it is going infinity, the decimal expansion, if it is going infinitely, you can say, but it is going with the pattern, those type of decimal expansion, we call it as non-terminating and recurring. Understood? Yeah. Next type of decimal expansion we have is non-terminating and non-recurring. Means what here? It is going infinitely also, plus it is not repeating also. Now when you take the pi value, you get a 3.142, like that it goes on forever, right? Although it is going forever, you are not getting some pattern here. Means in the previous what we saw certain pattern, right? For example, 2525, or you are getting only 33333. So these are certain patterns which you are getting. But here what happens? Here you are not getting any type of pattern. So this type of decimal expansion, we call it as non-terminating, non-recurring type of decimal expansion here. So when it comes to a rational number, when you take any rational number, in rational numbers, always you get only the first two type of decimal expansion. Means in rational numbers, you can only see terminating decimal expansion and non-terminating decimal expansion. So this all comes under rational numbers. But when you are getting non-terminating and non-recurring type of decimal expansion, then these types of numbers we call them as irrational numbers. Now video understood. So how can you separate a rational number and an irrational number? If the decimal expansion is terminating, or if it is non-terminating recurring, then it is a rational number. But if you are getting non-terminating and non-recurring expansion, then it is an irrational number. Now we're gonna solve certain questions which help us to understand the decimal expansions. The first question is 10 divided by 3. So when you divide 10 by 3, what you get? Find out. Okay, so we get 3 3s are 9, then 1 point if we keep, we get 0. Again you can write as 3 3s are 9, again 1, again you can get your 3, 9, 1, again here you get 10, again you will write 9, again it goes. So when you see here the quotient, you can say what type of quotient you're getting. You're getting, when you divide 10 by 3, you get 3.33333, which goes on forever. Okay, so if you divide it infinitely, it will get only 3 then. Okay, it goes on forever there. But there is one catch here. What is that catch? That it is going in a pattern. It is going in a pattern. So this type of decimal expansion is what? Non-terminating and recurring. It is non-terminating but recurring. Understood? Yeah. Now we'll take one more type of number and we divide them. Okay, clear? Yeah, that is your 7 by 8. Okay, so you divide it. So what you get? 8 divided by 7. So obviously you'll take here 0. So you'll get 0, 7. You'll get again point if you get, you'll get 70 here. So 8 Omad, so you will get 70. 8 it's a 64 you get, right? 8 8 is 64. So again you got here 6 as your answer. Then what? 8 7s are 56 you will get, right? Again you will get a 4 here. Then 40 you get, 8 5s are 40. So what you are getting the answer as? You are getting it as 0.875, and the remainder you are getting it as 0. So when you get remainder as 0, which type of decimal expansion is this? Obviously this is your terminating decimal expansion. So this is terminating decimal expansion there. Okay, now if you take root 2 value, you can say you will get some numbers there, 1.26 something. It goes on forever. So yeah, but it is going on forever, but it is not going in a pattern. So in the early what we saw, we got what? 0.3333. Now it is going in a pattern, but here it is not going in any kind of pattern. That is the reason it is an irrational number. Okay, so if you write q and if you write a bar, then it becomes an irrational number. Understood? Yeah. Now we can tell the difference between rational numbers and irrational numbers. So what are the differences we can find in rational and irrational is, first is irrational numbers. You can write them in the form of p by q. What you can write them in the form of? You can write them in the form of p by q. In irrational numbers, you can't write them in the form of p by q, right? Yeah. In rational numbers, we get decimal expansion in two types. Which are those? Terminating decimal expansion and non-terminating but recurring decimal expansion. Whereas for irrational numbers, we are getting only non-terminating and non-recurring decimal expansion. Now we got an idea difference between rationals and irrational numbers. Thank you for watching.